To design better systems, it is crucial to accurately assess the user experience. Among these, emotions serve as a key metric for evaluating entertainment and interaction. Emotion observation in such contexts often involves the use of questionnaires or physiological responses. However, these methods face the challenge of capturing diverse emotional changes in a time series approach. To address this challenge, Kawashima and Watanabe proposed the Ah-Aloud method. In this method, native Japanese-speaking participants are asked to vocalize only the exclamation "ah" as part of an evaluation experiment. Afterward, the experimenters analyze the emotions based on the prosody and intonation of the vocalized "ah." Among Japanese exclamations, "ah" has the potential to convey a wide range of emotions, including pleasure, distress, contentment, and excitement. An experimenter can directly observe and interpret these emotions from the participants' vocalizations. We aim to use the Ah-Aloud method to enable detailed evaluation and improvement of systems based on time series emotional changes. On the other hand, the Ah-Aloud method has not yet established a standardized analysis procedure. At present, this method has not yet fully captured time series emotional changes throughout the entire system experience. Additionally, since this method is limited to observing only 4 emotions, it remains unclear whether it can capture a broader range of emotions. In this study, we conducted a time series analysis of emotional changes using pleasure and arousal, and we organized the requirements for practical implementation of the Ah-Aloud method. Pleasure and arousal are metrics used in the effect grid, a tool proposed for reporting one's own emotions. In the effect grid, emotions are reported by rating pleasure and arousal on a 9-point scale from 1 to 9. The effect grid, based on Russell's circumplex model, enables quick and diverse emotion assessment by rating pleasure and arousal on a 1 to 9 scale. Experimenters analyzed their pleasure and arousal levels using a peer review format. Additionally, the relationship between the vocalized "ah" and the gaming experience was investigated. In this experiment, the game stimulus used was Sliding Penguin. In this game, the player controls a penguin, aiming to reach the goal without falling off the ice. After practicing the controls, 24 participants aimed to reach the goal within 60 seconds while vocalizing "ah" on the extended course designed to ensure sufficient playtime. 2 experimenters independently watched the gameplay videos with "ah" vocalizations, rating pleasure and arousal every second on a 1 to 9 scale. The 59th second vocalization was recorded as a neutral 5-5, and seconds without vocalization were marked as 0, as emotions could not be inferred. After each experimenter's analysis, discrepancies were resolved through discussion to determine a single emotional rating. This shows the distribution of pleasure and arousal ratings for each experimenter. Out of 1,440 responses, 977 for pleasure and 966 for arousal were in agreement. Additionally, the calculation of Cohen's weighted kappa coefficient revealed that for all participants, both pleasure and arousal exceeded 0.95. These results suggest that emotion measurement using "ah" vocalizations and the corresponding game screens may be less influenced by individual differences among experimenters. Based on the pleasure and arousal levels determined for each second through discussion, we analyzed the time series changes in participants' emotions. The results revealed a sharp decline in both pleasure and arousal levels just before the timeout, which is likely reflective of emotions such as disappointment and dejection due to the inability to reach the goal. Additionally, there was a noticeable increase in arousal levels around the last 5 seconds. This is likely indicative of emotions such as anxiety and stress in response to the approaching time limit. Furthermore, we visualized and analyzed the average values of pleasure and arousal, as well as the percentage of participants who were about to fall on each ice block within the course. The analysis revealed that, in many cases, ice blocks with a higher percentage of nearfalls were associated with lower pleasure and higher arousal levels. This suggests that feelings of anxiety and stress when the penguin was about to fall may have been expressed as emotions. These results suggest that the emotions observed through the vocalized ah are correlated with several in-game parameters, such as the remaining time and the penguin status. This implies that the Ah-Aloud method may have the potential to capture emotions expressed during the gaming experience accurately. On the other hand, several instances where discrepancies were likely to occur between the two experimenters were identified, and the authors considered the potential causes of these inconsistencies. First, a case was observed where pleasure ratings disagreed when volume and tone increased. This suggests that determining whether increased volume and tone indicate pleasure or discomfort may be challenging. Secondly, a case was observed where arousal ratings disagreed after post-breath vocalizations. This suggests that it may be difficult to determine whether changes in volume and tone after breathing reflect emotional expression. Third, a case was observed where slight changes in volume and tone led to discrepancies in pleasure and arousal ratings. This suggests that it may be difficult to determine whether subtle changes in volume and tone indicate emotional expression. Considering these points, establishing an analysis method for the Ah-Aloud method will require more detailed investigation into the relationship between the prosody of ah and the levels of pleasure and arousal. This study suggests the potential usefulness of the analysis method using pleasure and arousal in the Ah-Aloud method, but there are many limitations as this is an initial investigation. First, due to the involvement of only 2 experimenters, there are concerns about the reliability of emotion attribution based on the vocalized ah. Additionally, since ah is a Japanese interjection, the study is limited to Japanese participants. While it may be possible to observe emotions by adjusting interjections according to the language, this has not yet been tested. Furthermore, as this study focuses on a single game, it remains unclear whether the method can be applied to other types of content. To overcome these limitations and establish the Ah-Aloud method, further research is needed. Moving forward, we will enhance the reliability of the emotion observation method and explore its applicability to broader system evaluations. Specifically, we plan to increase the number of experimenters, apply interjections in other languages, expand the range of content being evaluated, and further explore its application to system evaluation.